Okay, ladies and gentlemen, let's take a look at cones. Now, if we're going to take a look at cones, we need to be able to talk about what they are. A cone is really nothing more than a pyramid like this one, except that for a cone, its base is actually circular. So you have something that looks broadly like this. Now, if I'm looking for volume of that cone, I'm going to use this formula similar to a pyramid. Now, for a prism, we remember that volume equals big base times height, whatever the base of that is, whether the base is a rectangle, whether the base of that is a hexagon, doesn't make a difference. Volume equals base times height. Now, for a pyramid, we did volume equals 1/3 big base times height. And the thing we have to remember is that the base can change. The base could be a nice square like this, and if that's the case, you have 1/3 length times width times the height of the figure. Now the height of the figure goes straight down and would be this height right through here, not down the side, but all the way directly through. So you have that. You could also have something like this. It is also a pyramid, but you'll notice in this case, the base is indeed a triangle. So what we're looking for a cone is we're going to basically steal this formula. Volume equals 1/3 base times height, but the base of every cone is a circle, so it's pi r squared. So in this case, let's say I have a radius of 4 units and a height, and remember the height goes right down the middle. Let's say we have a height of 6 units. So if that's the case, volume equals 1/3 parentheses pi r squared, so radius was 4 squared, times height, which is 6. So I say 1/3 pi 16 times 6. Do a little canceling here. I get 2. And I'm going to get 32 pi and whatever 32 pi is. So grabbing a calculator, if I want to find an actual estimate here, I take 32 times approximately 3.14, and I would get 100.5 approximately. Now I say approximately because you have to understand all decimals are really just approximations. They are not exact. Decimals are approximations. So we have volumes of cones. Not really a big challenge. It's the same basic process we've worked off of. Do also remember that for the same reason in displacement that we talked about earlier, that even if the cone is off-center, such that, let's say, the height goes to one edge of the cone instead of the middle, that the volume itself is still going to be the same as 1/3 pi r squared h. So there you go. I'm also going to include the link to another little video on showing you liquid-wise why volume of a cone or volume of a pyramid is 1/3 the volume of its corresponding full dimensional shape. So take a look from there.